One of our frequently asked questions is, well, what about database security? It's a huge and important topic, and what I'd like to do right now is talk about one of the techniques that you're already using in order to help keep your databases more secure. I want to talk about this technique because as long as you understand it, you're more likely to use it rather than find shortcuts. Okay, so we've connected your Flask projects to your MySQL database using PyMySQL. And we've asked you to construct your queries now like this, where you set up your query and you tell it, hey, I want to select all from users, for example, where email equals, and then you just leave a placeholder here. You're leaving a placeholder here because you're not sure yet. You need to find out from your user what that email is going to be. You then pass in that user input in a dictionary, and I'm going to just call my dictionary as data. The key in the dictionary matches that placeholder, and then you can put in the value right here. And so in this case, the user is passing in an email through the form. Then you're going to pass both that query and the data dictionary to the QueryDB method of your PyMySQL library. Okay, so a lot of you may have noticed that this seems like extra work. Why would I make a data dictionary when there are simpler ways to get this data into our query string? Okay, and so that's a really good observation, and I commend you if you notice that it does seem a little tedious. But I'm here today to try to convince you to keep doing it the tedious way, and let's not take shortcuts. Okay, so the shortcut method might look something like this, where you just use literal string interpolation, and you just say select all from users where email is equal to, and then you just plug in what they typed in, all right? That's one way that you could do that. And it would work, right? Because then all you would have to do is just pass in that query to your QueryDB method, and it would totally work. You would test it out, and you would say, this works fine. I'm not going to bother with this data dictionary. And the problem with that is that you've now left yourself vulnerable to SQL injection. SQL injection is when a user can send you SQL code. And so if you put SQL code in here, then there's the possibility that your database will just run it, right? It's going to just say, okay, I'm running SQL code, and here's just some more SQL code. And if a user succeeds in doing that, then they can make your database do what they want your database to do instead of what you wanted your database to do. So how would they do this, right? How can they possibly send you SQL code? Well, if you gave them a form where they can type in their email, then there's nothing stopping them from maybe doing something like this. They'll type in an email, for example. Doesn't even have to be. Maybe they'll type in nothing. But they'll put in this quotation mark. And that's really dangerous because quotation marks mean something in SQL. Then they'll say or 1 equals 1. And then they'll not have a quotation mark over here. Okay, now why? What's going on here? Well, in order to really explore this, we'll have to think about what did you just give the user, right? What did you ask them to do? You asked them, basically, to fill in the blank. That's what you're doing here with literal string interpolation. You gave them this query and you said, okay, it's up to you now, fill in the blank. And here's what this person chose to do. Let's just take what they typed in right here and plug it in right here. There we go. There's our entire SQL query now. So you can see that the dangling quotation mark that was here has been closed by us in the server. Okay, so now we have a completely different SQL query. Probably looks a lot different from what we intended. Because now it says, select all from users where email is equal to joe@gmail.com or 1 equals 1. And when we have this or statement, that means that only one side of the equation has to be true for it all to be considered true. And of course, 1 equals 1 will always be true. So now, as we go through the users, all of our users in our users table, we're going to be saying, hey, for this user, does 1 equal 1? Well, yeah, 1 equals 1 no matter who you are. So now this is going to be returning all of the users instead of just the one that you intended. This is really, really dangerous. You're allowing a user to send in SQL code, and you're going to accept that code and make your database do it. This could be especially dangerous if you could allow them to do something like add in some code that says drop table users. That would be absolutely tragic. So SQL injection is incredibly dangerous. And let's do another example. This one I'm going to share my screen for. You're going to see that I made a little app where you can search my inventory. So what kinds of things am I selling? Coffee, of course. So let's search and let's see what we've got. We have some coffee and we have a coffee cup. And of course I'll sell ice. Who doesn't sell ice? So we have ice cubes and ice cube trays, right? So you can start to think about what kind of query is happening in the back end to make this possible. So of course it's a kind of filter, right? We're being kind of loose. It doesn't have to be an exact match. So we're probably using that like statement. So if you want to pause the video now and think on your own what the query might be, I'd highly recommend it. So what'd you come up with? So the query that's probably happening in the back end is probably something like select all from some table. Maybe it's called products. You'll see that it doesn't matter. I don't need to know what that table name is. I just need to know the basic structure. Select all from products where, and again, I don't know exactly what that field is. Maybe it's name, but again, it doesn't matter. Just going for the basic structure. And it's going to say like, and then I might have this quotation mark, percentage sign, and then I would put in whatever user input I've got. Percentage sign, close the quotes. Yeah, that's probably what my query is. Select all from products where name like, and then they can type in whatever they want. And as long as whatever they typed is somewhere in the name, it will come back. Okay, so now we can start thinking about how can I use this to my advantage. So kind of like in this query, what happened was as long as we closed that quote, then we were free to kind of extend the query or write our own SQL code. So the same thing's happening here. We have this quotation mark, and we'll need to close off that quotation mark. So we can start off by saying, I'm going to search for ice and then close the quotation mark. After that, I can do whatever SQL code I want. So one of my favorites is the union command. If you don't know that one, it means that it's going to take the table from the first select statement, and then we can put in another table. So for example, I can just say union, and then I can just say select all from users. Okay, and so then that might be the end of the query that I want to do. I just want to see if I can get that table from querying the products table and then just stick on the bottom the users. Let's see if that works, okay? The problem that I have right now, though, is that my user input's here, and I'm still going to have this percentage sign and this quotation mark trailing at the end. And then I'll have a syntax error, and then nothing will run, and then I'm in trouble. So I need to get rid of this percentage sign and the quotation mark. So let's just comment them out. So a hashtag in SQL is a comment out anything to the right. So now I've just gotten rid of that. So let's just take this and plug it into our text field and see what happens. So I'm going to go back to my app, and I said that I would search for ice, and then union, select all from users, and then comment out anything that comes afterward. Okay, and let's search. Okay, it didn't work. But I'm not going to despair quite yet, because there are a couple reasons why that might not have worked. And one of them could be that well, the union command will only work if the table on top and the table on bottom have the same number of columns. So I need to find out how many columns I'm actually getting back by searching the products table. I know it's at least 2, because I saw in my results that I get the name of the product as well as the price. But there's probably more that came back that weren't being displayed to me. So I can start guessing. And again, there are other queries that you could do to not have to exactly guess, but you could poke around in the database, see what's available to you. But you can get pretty far with just kind of experience and kind of knowing how people generally set up their databases. So let's just start guessing. I know that there's at least 2 things in the table. Let's try, maybe there's 4. So let's copy that again and search. Okay, we got nothing. Let's try 5. And that time it responded. Okay, so it came back with nothing interesting, but the fact that it responded is itself very, very, very interesting. It means that it's reading my SQL code and it's giving me answers. Okay, so let's come up with a more interesting query. All right, so I'm not going to just select 1, 2, 3, 4, 5. I know now that as long as I provide 5 things to search for, then the tables will match up and it will be stuck onto the bottom of my results from searching the products table. Okay, so again, we could query around and find out what kinds of things are available to us, but experience tells us that in the users table, we probably have ID. Of course, what I'm really after is the passwords. There's probably first name in there, last name, and maybe email, right? So that's 5, right? ID, password, first, last, yeah, email. Okay, so that's 5 things. So let's search. There you have it. So I was able to find my users and I was able to find their passwords. So please don't do this. This is illegal. Please don't get yourselves in trouble. But just know that this is something that you have to protect yourself against. In my case, this is my own app. These are fake people. I don't think anybody cares. So let's just take a look at the code that made this possible. So you can see here in the code, I was using literal string interpolation. I took the argument that came in through the URL and I just stuck it in here. And then I just ran with it. So you can see here I printed the queries. If you want to go over to the terminal, you can see that this was the query. So it just took exactly what I had typed into the text field and produced that query and ran with it. All right, so how would we do this properly? We wouldn't use literal string interpolation. We would instead use the prepared statements. And we would pass both the query and that data dictionary to our PyMySQL library. Okay, so let's save that. And now let's see if this query is going to produce anything. So with the prepared statement, this isn't going to work. And that's a good thing. That's really, really good. So what the prepared statement does is it doesn't read special characters like quotation marks or equal signs. It doesn't read those as SQL code. They're just strings. So what I essentially did was I had just asked, is there a product that's called ICE union select ID password first name last name email from users hashtag? And there probably wasn't. Yeah, so if there was a product that was named that, I'd probably want to buy it. But in this case, it doesn't exist, and so that's all we get. Okay, so this is just the bare minimum that you have to be doing in order to protect your databases. Please use prepared statements. It's the best that we've got. And until something better comes out to protect our databases, we got to stick with prepared statements. So don't get lazy. Keep using your prepared statements, and we'll be talking about some other measures that you should be taking in the next module.